Let's review once again about the metathesis reaction, which is the ionic equation. And as we know, metathesis reaction, this is an example of precipitation reaction. Describe what ions are present in the solution and what are the involved in the reactions. So when silver nitrate react with potassium iodide, it forms silver iodide and potassium nitrate. So all these compounds are ionic compound. When we will dissociate them, then how we will write this? Silver nitrate will form silver ion plus nitrate ion. Potassium iodide will separate into potassium and iodide ion. Silver iodide will not precipitate, not ionizes, it will precipitate. That is why it's not ionizing. And potassium nitrate will dissociate into potassium and nitrate ion. So if you will see in the complete ionic equation, what will happen here? Basically, you can see the two ions, nitrate ion and potassium ion, are on the reactant side as well as on the product side also. So these two ions are called spectator ions. So those ions which are on both the side remain, they are called spectator ion. And if we will write the net ionic equation, so net ionic equation will be silver ion is reacting with silver iodide ion, it is forming silver iodide. So that is the mainly ionic reaction, and these ions are called spectator ion. So definition of the spectator ion is present on both side of the complete ionic equation and not involved in the actual reaction which is taking place. So spectator ion are those ion which are present on both side, but they do not participate in any chemical reaction. Let's see. So in this reaction, as we have seen that these two ions are called the spectator ion because they are not participating, and the net ionic equation will be silver ion plus iodide ion will be silver iodide. So net ionic equation, the definition of net ionic equation is the reaction which remain after the spectator ion are cancelled from the complete ionic equation. So we can cancel these spectator ion and remaining these species will remain. So they will make net ionic equation. So if you summarize all these three slides, it would be like first we have to make a ionic compound, and based on the solubility chart you have to remember that iodide of the silver and mercury and they will not ionizes and they will precipitate. So we cannot ionize the silver iodide, and we have to find out which were the spectator ion, and then we have to cancel those one, and then we'll get the net ionic equation. So next is how to determine the net ionic equation. Procedure for determining the net ionic equation: determining if each substance is dissolved, and determine whether the soluble substances are strong electrolyte, weak electrolyte or non-electrolyte. And third is they must be dissociate the soluble and strong electrolyte and omit the spectator ion from the reaction. So these four rules will be considered in determining the net ionic equation. So we will see some more example, then we can understand these rules much better. So for an example, sodium sulfate when react with the barium nitrate and barium sulfate, and then sodium nitrate will form. So when we will write the ionic equation for this one. We will dissociate the sodium ion, sulfate ion, and barium nitrate all as well as. So mainly, if you in this type of reaction, you will notice that reactant side mostly everything will ionize compared to the product side. So product side we have to figure it out based on the solubility rule. If any product will dissolve or not, so how we will find out this one? And if you remember this slide where it is written sulfate of strontium, barium, mercury and lead will are the exception from the soluble ionic compounds. So from this table we know that barium sulfate will not dissolve and it will precipitate. So if it is precipitating, we cannot ionize this one, and then we have to find out the spectator ion from both sides, which are sodium ion and nitrate ion. So we can cancel these two, and then the remaining species will make net ionic equation. So this is called net ionic equation for this reaction. Another example is barium chloride. Barium, when react with this silver nitrate, it forms barium nitrate and silver chloride. So again, mostly in the reactant side you will see all the ionic compounds are dissolved and they are ionizing into ions: barium ion, chloride ion, silver ion, nitrate ion. And on the product side only one or few reactants dissolve and one of them not. So silver chloride, and again if you will review this table, so silver chloride, so you can see in soluble ionic compound silver, mercury and lead chloride are exception, so they will not soluble, they will not dissolve. So sodium silver chloride is not dissolving. So we can cancel the spectator ions. These guys will be cancelled out, and the net ionic equation will be chloride plus silver ion is equal to 2 AgCl. So this will be net ionic equation. Next example is sodium acetate and nitric acid. Sodium acetate is a salt of acetic acid, and nitric acid is strong acid. When dissolved it forms vinegar, acetic acid and sodium nitrate. So again acetates, let's review this table. So you can see soluble ionic compounds, acetates are mostly soluble, but this is a acid, acetic acid. So acetic acid is weak acid. So for this reaction you have to consider the acid, which acid is a weak acid, which acid is a strong acid. So sodium and nitrate in this reaction are the common or spectator ion on both sides, so we can cancel out, and the remaining reaction or remaining ionic equation will be, net ionic equation will be acetate ion. When react with or when hydrogen ion, it produces acetic acid. Fourth example is zinc sulfide, and when react with HCl, zinc chloride form and H2S gas form. So basically in this reaction you can see zinc sulfide is written already. Solid means they are using as a precipitate form. When dissolved in HCl, HCl will be in the ionic form, and this will form zinc ion and chloride ion, and H2S gas will form. So gas will evaporate from this reaction. But when you will find out the spectator ion, so chloride ion are the only ion which are on both sides, so they will be cancelled out, and remaining species will be added in the net ionic equations. So these are some example of net ionic equation and spectral ions, and you can review some more examples so you can have better practice.